Welcome to another video by Team Matcom. In this particular video, we will be discussing a question from the chapter Gravity that belongs to class 11 Physics. So the given question is, consider the three billiard balls of masses 400 gram each placed on a table at the corners of a right angle triangle as shown in the figure. Calculate the gravitational force vector on the ball of mass m1 resulting from other two balls. Also find the magnitude and direction of this particular force. So we have three masses m1, m2 and m3 that is placed on the corners of a right angular triangle. They have given that the mass m1 equal to m2 equal to m3, that is equal to 400 gram, that is nothing but equal to 4 by 10 kilogram. How can you get 4 by 10 kilogram? This particular 400 gram can be converted to kilogram by multiplying with the 10 raised to minus 3. It will become 0.4 kilogram. 0.4 kilogram is nothing but equal to 4 by 10 kilogram. 0.4 kilogram is nothing but equal to 4 by 10 kilogram. Clear? So each mass is 4 by 10 kilogram. Now, what we need to calculate? Now, we need to calculate the gravitational force vector on the ball of mass m1. So on this particular ball resulting from other two balls. So when you're considering the masses m1 and m3, they are separated by a distance of 0.4 meter. So we can calculate the force of gravitational attraction between m1 and m3, that is F31 is equal to F31, which is equal to G into m1 m3 divided by R13 the whole square. So R13 square. So what is the value of G? G is equal to 6.67 into 10 raised to minus 11 into m1 is 4 by 10. M3 is also 4 by 10 divided by R13 is 0.4, nothing but equal to 4 by 10 the whole square. This 4 by 10 the whole square and 4 by 10 and 4 by 10 can be cancelled. So you will be getting it as 6.67 into 10 raised to minus 11 Newton. 6.67 into 10 raised to minus 11 Newton. Here you can see that this particular force F31 which is acting along the x-axis. So this particular vector can be written as 6.67 into 10 raised to minus 11 I cap Newton because it is acting along the x-axis. In the same way, between the masses m1 and m2, the force of attraction is F21. So what we can write? The F21 is equal to G into m1 m2 divided by R12 square. What is the value of G? 6.67 into 10 raised to minus 11 into m1 is 4 by 10, m2 is also 4 by 10 divided by what is the distance between them, that is 0.5 meter. So this can be written as 5 by 10 into 5 by 10 because 5 by 10 the whole square. So we can cancel. So we can very clearly we can cancel this 10 and this 10. These two 10s can be cancelled because it will become reciprocal. So what you will be getting? You will be getting 6.67 into 10 raised to minus 11 into 16 divided by 25. On simplification, when you simplify these values, on simplifying these values, you will be getting it as 4.268 into 10 raised to minus 11. Since F21 force is acting along the y-axis, so as a vector component, we can write it as J cap Newton. So we got two forces. One force that is F31 that is acting along the x-axis, and we have another force that is F21 that is along the y-axis. So we have a resulting vector that is F, resulting vector F. So assume that if theta is the angle between these two vectors, theta is the angle between F31 and F21 mean, the resulting vector F can be calculated as square root of F31 square plus F21 square plus 2 F31 into F21 into cos theta. This is what we are obtaining from the parallelogram law of vector addition, because if you have two vectors, let it be A and B, if it is an angle of theta mean, the resulting vector R is equal to square root of A square plus B square plus 2AB cos theta. This equation we are using here. Since F21 and F31 are perpendicular to each other, theta is equal to 90 degree, cos 90 is equal to 0. So this component will vanish. So remaining you will be having F31 square plus F21 square because cos 90 equal to 0. So that is why this component will vanish because theta is equal to 90 degree. So this can be written as the square root of 4.268 into 10 raised to minus 11 the whole square, that is 4.268 into 10 raised to minus 11 the whole square, plus what is f31 value? F31 is 6.67 into 6.67 into 10 raised to minus 11 the whole square. You can take 10 raised to minus 11 the whole square outside. So you will be getting square root of 10 raised to minus 11 the whole square into 6.67 square plus 4.268 square. 4.268 square. So you can take 10 raised to minus 11 the whole square outside. So you will be getting 10 raised to minus 11 into square root of 6.67 square plus 4.268 the whole square. So if you do the simplification, if you do, for example, if you're taking the square of 6.67 and if you take the square of 4.268, add and taking the square root, you will be getting it as 7.918 into 10 raised to minus 11 Newton. So this is the value of the resultant force. So now we got the value of the resultant force also. So this is F21 and this is F31. This is the resulting vector F. Assume that alpha is the angle between the resulting vector with the F31 mean. This will also become equal to F21. So if you take tan alpha equal to opposite side by adjacent side, that is F21 by F31. What is the value of F21? F21 is 4.268 into 10 raised to minus 11 divided by F31 is 6.67 into 10 raised to minus 11. 10 raised to minus 11, 10 raised to minus 11 cancel. Remaining we have 4.268 by 6.67, that will give you 0.639. Therefore, alpha is equal to tan inverse of 0.639, that is equal to 32.6 degree. So we got the angle between the resulting vector with the x-axis. So we have calculated what is the net force acting on the body with a mass m1 and what is the direction at which it is acting. Hope the video is useful. If you need any clarification, do let us know in the comment section. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel. Keep watching, keep learning. Thanks for watching. Bye.